After studying this module, you shall be able to know the meaning of equilibrium, understand the existence of equilibrium, identify the problems in the existence of equilibrium, learn about the stability and uniqueness of equilibrium.
After studying this module, we shall be able to know the meaning of equilibrium, understand the existence of equilibrium, identify the problems in the existence of equilibrium, and learn about the stability and uniqueness of equilibrium. The concept of equilibrium forms the core of economic theory. Modern economics is known as equilibrium economics. The concept has been derived from two Latin words, equus, which means equal, and libra, which means balance. So, the term equilibrium means the state of balance from which there is no tendency to move. An equilibrium may or may not exist. Apart from the existence problem, two other problems are associated with an equilibrium: the problem of its uniqueness and the problem of stability. These problems can best be understood with the partial equilibrium example of a demand supply model. Like any economic term, it can be defined in various ways. For example, Professor Marshallian, an equilibrium is a constellation of selected interrelated variables so adjusted to one another that no inherent tendency to change prevails in the model which they constitute. This concept has been clarified by Professor Skitowski by stating that a person is in equilibrium when he regards his actual behavior as the best possible under the circumstances and feels no urge to change his behavior so long as circumstances remain unchanged. The same is true to the equilibrium of a firm and that of an industry. Thus, equilibrium means the position reached by the individual, the firm or the industry from which there is no tendency to move. From the point of view of an individual consumer, equilibrium will be reached at a point when he gets maximum satisfaction from his given income spent on different goods and services. Similarly, for an individual producer, equilibrium position will be attained when he gets maximum profit. The industry will be regarded to be in equilibrium when there exists no tendency for the size of the industry to change. All this discussion boils down to the fact that an equilibrium position is that where everyone in the whole system believes that he or she cannot improve its lot by altering its behavior. It is clear that in a perfectly competitive market of a particular commodity, an equilibrium price is obtained when the quantity offered by sellers at that price equals the quantity demanded by the buyers. It implies that the forces of demand supply operating in such a market are in balance. That is, the intersection of the demand supply schedules will determine the market equilibrium price.
Let us try to understand the meaning of equilibrium. Like any economic term, equilibrium can be defined in various ways. According to Professor MacLup, an equilibrium is a constellation of selected interrelated variables so adjusted to one another that no inherent tendency to change prevails in the model which they constitute. The concept of equilibrium has been clarified by Professor T. Sitovsky by stating that a person is in equilibrium when he regards his actual behavior as the best possible under the circumstances and feels no urge to change his behavior so long as circumstances remain unchanged. The same is true to the equilibrium of a firm and that of an industry. Thus, equilibrium means the position reached by an individual, the firm, or the industry from which there is no tendency to move. From the point of view of an individual consumer, equilibrium will be reached at a point when he gets maximum satisfaction from his given income spent on different goods and services. Similarly, for an individual producer, equilibrium position will be attained when he gets maximum profit. The industry will be regarded to be in equilibrium when there exists no tendency for the size of the industry to change. That is, when no existing firms want to leave the industry or no new firms wish to enter into it. All this discussion boils down to the fact that an equilibrium position is that where everyone in the whole system believes that one cannot improve his lot by altering his behavior. It is clear that in a perfectly competitive market of a particular commodity, an equilibrium price is obtained when the quantity offered by sellers at that price equals the quantity demanded by buyers. It implies that the forces of demand and supply operating in such a market are in balance. That is, the intersection of the demand and supply schedules will determine the market equilibrium price. Let's understand market equilibrium with the help of a diagram. On x-axis, we are measuring quantity and on y-axis, we are measuring price. Consumers attain equilibrium at every point on the demand curve D since it represents their planning curve and embodies their maximizing behavior. At every point on the supply curve, producers attain equilibrium in the sense of maximizing profit or minimizing cost. Since point E lies on both demand and supply curves, consumers and producers' equilibrium coincide. Their chosen positions are mutually consistent. Also, at point E, the market for the good is at rest. The opposing forces are in balance. PE and QE are equilibrium price and equilibrium quantity respectively. Let's now discuss the necessary conditions for existence of equilibrium. It's necessary to emphasize that both demand and supply schedules must intersect for existence of an equilibrium. Mere downward sloping demand and upward sloping supply schedules do not ensure that both will intersect and an equilibrium price will be determined. In other words, there is no guarantee that equilibrium will exist. Even when the demand curve is downward sloping and supply curve is upward sloping, there can be situations when equilibrium does not exist at all. In the situation depicted, no equilibrium is possible even though demand curve is downward sloping and supply curve is upward sloping. In the first case, there is no positive price at which demand equals supply. In fact, even at zero price, there is excess supply. This is particularly true for the free goods of nature, such as clean air, open space, etc. However, this can change over time. For example, clean air was once free, but the increasing industrialization and deforestation has put now same social value or price on it, although not a market price as yet, since we are becoming conscious of environmental constraints upon economic growth. In this case, the minimum price at which the good will be supplied exceeds the maximum price the buyers are willing to pay. Hence, there exists no market for the commodity in question and thus no equilibrium is possible. Let's now analyze the problem in existence of equilibrium. We can use an alternative way of analyzing the problem of existence of equilibrium by using an excess demand function. The term equilibrium means a state of balance. It occurs when desired purchase equal desired sales. When at a particular price quantity demanded equals quantity supplied, we say market is in equilibrium. At such equilibrium price, there is neither excess demand nor excess supply. An equilibrium price can be defined as the price at which the excess demand is zero. At a price below equilibrium price, demand exceeds supply and hence excess demand is positive. As price keeps on falling, positive excess demand goes on increasing. Now, at a price above the equilibrium price, supply exceeds demand and hence excess demand is negative. As price keeps on rising, negative excess demand tends to increase. Let's look at the cases of equilibrium and cases of no equilibrium. The excess demand curve as a function of price is downward sloping. In case 1, equilibrium exists at P1 and the equilibrium price is OP1. For equilibrium to exist, demand and supply curves must intersect at some positive price. In case 2, no positive price exists as excess demand is zero. Hence, no equilibrium. Even at zero price, excess demand is negative. Such a good must be a free good, that is, air. In a case of multiple equilibria, equilibrium will not exist. Within the price range P1 to P2, excess demand is equal to zero. This implies demand is equal to supply for all those prices leading to more than one equilibrium points. Let us study two cases where equilibrium will not exist. In the figure, the excess demand function has a gap in the price range P1, P2. At a price above OP2, no demand is forthcoming, and at price OP1, no supply is forthcoming. Equilibrium does not exist. In figure, the excess demand function is rectangular hyperbola and lies in the non-negative quadrant. At a very high price, excess demand tends towards zero but never actually becomes zero. The curve is asymptotic. The curve comes closer and closer to x-axis and y-axis but never touches them. Hence, no equilibrium is possible. Thus, the existence of equilibrium is related to the problem whether the consumers and producers' behavior ensures that the demand and supply curves intersect at some positive price. Uniqueness of equilibrium. Existence of equilibrium is no guarantee that such an equilibrium will be unique. Uniqueness implies that there exists only one positive price at which demand equals supply or excess demand for the good equals zero. However, in some situations, there exists more than one positive price at which demand equals supply. Such possibilities arise when either the demand curve or the supply curve or both the curves do not behave normally. In figure, demand curve DD and supply curve SS intersect each other at E2 where OP2 is equilibrium price and OQ is quantity demanded as well as quantity supplied. If price increases to OP1, then the new equilibrium will be at point E1 where the quantity demanded and quantity supplied remain equal at OQ. Thus, between the price range P1, P2 or E1, E2, there are multiple equilibrium points. For example, multiple equilibrium arises when a negatively sloping demand curve is intersected by a backward bending supply curve at more than one point, as shown in figure. Supply curve SS intersects demand curve DD at points R and K, yielding multiple equilibria. The cases of multiple equilibria are however rare and not of much practical importance. Stability of equilibrium. An equilibrium can be stable or unstable. A stable equilibrium means that both price and quantity would converge to some point if disturbed, or loosely speaking, the state of balance between forces of demand and supply will be restored. On the other hand, unstable equilibrium is characterized by imbalance between the demand and supply forces, hence, price has a tendency to move away from the equilibrium point. Stability of equilibrium can be analyzed using two adjustment hypotheses. First, Walrasian adjustment process. Second, Marshallian adjustment process. Walrasian adjustment process. The Walrasian adjustment process works through price movements. The Walrasian stability conditions state that when excess demand is positive, buyers tend to raise their bids, and if negative, the sellers tend to lower their prices. In other words, Walrus assumes that it is price that adjusts itself to quantity changes. The excess demand price is defined as the difference between the price that buyers are willing to pay and the price that sellers are charging for a given quantity. Mathematically, the excess demand at price P can be defined as EP is equal to dP minus SP. It is positive when demand at price P is greater than supply at price P. It is negative when demand at price P is smaller than supply at price P. Let's understand the concept of price movements under Walrasian adjustment process graphically. On x-axis we have quantity of good and on y-axis we have price of good. DD is negatively sloped demand curve and SS is positively sloped supply curve. When excess demand is positive, that is, P1F is greater than P1C, the quantity demanded is greater than the quantity supplied. The buyers will bid the price upward, and when the price rises, demand falls and supply increases, and the initial equilibrium position is reached at E. If the excess demand is negative, that is, P1F is greater than P1C, the quantity supplied is greater than the quantity demanded, The sellers will lower the price from OP2 to OP. Thus, according to the Walrasian stability condition, when excess demand is positive, then the buyers will increase the price, and if it is negative, then the sellers will reduce the price, as a result of which the equilibrium position is restored at E as shown. Marshallian adjustment process. The Marshallian adjustment process works through quantity movements. The Marshallian stability condition states that producers will tend to increase the supply of the product when the excess demand price is positive and will reduce it when it is negative. In other words, Marshallian analysis is based upon assumption that quantity adjusts to price changes. Let's understand the Marshallian adjustment process graphically. On x-axis, we have quantity of the good, and on y-axis, we have the price. When excess demand price is positive, AQ1 greater than CQ1, that is, the demand price is greater than supply price, it means that consumers are ready to pay more price than is being charged by the producers. This will induce the producers to increase the supply from OQ1 to OQ, which will lead to a decrease in price and then again leads to increased demand, as a result of which equilibrium will be restored at the initial equilibrium position E. On the other hand, when the excess demand price is negative, FQ2 less than BQ2, that is, the demand price is less than supply price. It means that the consumers are willing to pay a lower price than is being charged by the producers. This will induce producers to decrease the supply, which will lead to increase in price, and that again leads to increased supply, as a result of which equilibrium will be restored at the initial equilibrium point E. Let's now compare both the analysis. It is clear that the conditions of stability given by Walras and Marshall are satisfied simultaneously if the demand curve is negatively sloped and supply curve is positively sloped. According to Walras, equilibrium is defined as the price which equates quantity demanded and quantity supplied. In Marshallian analysis, equilibrium is defined as the quantity which equates demand price with supply price. In case the supply curve is negatively sloped, the two stability conditions cannot be fulfilled simultaneously. Rather, both will hold in opposite directions. If an equilibrium is stable in the Marshallian sense, then the equilibrium will be unstable in the Walrasian sense and vice versa. Let's look at the comparison between Marshallian and Walrasian analysis graphically. We may explain it with the help of negatively sloped supply curve which intersects the normal demand curve at several points. A, B, and C are 3 points of equilibrium where quantity demanded is equal to quantity supplied. P1, Q1, P2, Q2, and P3, Q3 are price and quantity corresponding to points A, B, and C respectively. According to Walras, The successive equilibrium points A, B, and C are alternatively stable and unstable. The demand curve intersects the supply curve from below at A and C, and therefore the equilibrium is stable at these points. In other words, the supply curve is steeper than the demand curve at A and C, which is why the equilibrium is stable. Similarly, the demand curve intersects the supply curve from above at point B. The equilibrium is unstable. In other words, the supply curve becomes less steep than the demand curve at point B, which is why the equilibrium is unstable. Equilibrium points A and C are Walrasian stable but Marshallian unstable, and equilibrium point B is Walrasian unstable but Marshallian stable. Now, according to Walras, when price is above OP1, it will fall as excess demand is negative here. Price will rise between P1 to P2 and will fall between P2 to P3. Price will rise between 0 and OP3 as here excess demand is positive. According to Marshall, quantity will increase when excess demand is positive and will fall when excess demand is negative. So, above OQ3 quantity will increase, between Q2 and Q3 it will fall, then again rise between OQ1 to OQ2 and will fall below Q1. On the other hand, according to Marshall, if the demand curve lies above the supply curve and then the former intersects the latter as on points E and G, the points of intersection will result in stable equilibrium. On the contrary, if the demand curve lies below the supply curve and the point where they intersect, point F, will be a point of unstable equilibrium. This figure shows equilibrium points E and G are Walrasian unstable and Marshallian stable, whereas equilibrium point F is Walrasian stable but Marshallian unstable. Here, according to Walras, price will increase when excess demand is positive and vice versa. We can see this with the help of arrows. According to Marshall, quantity will rise when demand is greater than supply and vice versa. Thus, the two approaches given by Marshall and Walras regarding the stability conditions of equilibrium are just opposite to each other. It is because both Marshall and Walras have taken different time periods in their analysis. Walras has explained stability and instability, assuming a short period in which adjustment is made by changes in price. Walras viewed adjustment process as a price correction process, short-run adjustment process. Marshall, on the other hand, defines stability conditions in the context of equilibrium in which the adjustment is made by quantity changes. Marshall viewed adjustment process as a quantity correction process, long run adjustment process.
We will now summarize our findings. Essentially, what we have discussed in the module is that firstly, equilibrium in a competitive goods market implies that the forces operating in the market from the demand side exactly balance the forces operating in the market from the supply side. The excess demand for goods X is defined as the difference between demand of good X and supply of good X. At equilibrium, demand for good X should be equal to the supply of good X, and hence excess is 0. Even if equilibrium exists, there is no guarantee that such an equilibrium will be unique. Uniqueness implies that there exists only one positive price at which demand equals supply, or excess demand for the good equals 0. There are situations where more than one positive price prevails. In such cases, we have multiple equilibrium, more than one set of price at which demand and supply forces are in balance. Such possibilities arise when either the demand curve or the supply curve do not behave normally. The stability equilibrium has been discussed using the Walrasian and the Marshallian adjustment process. Walrasian adjustment process works through price movements, while the Marshallian adjustment process works through quantity movements. In Walrus, equilibrium is defined as the price which equates quantity demanded and quantity supplied. In Marshall's, equilibrium is defined as the quantity which equates demand price and supply price.